and they've got older type systems in there. And they're very low efficiency systems using belt drives or even old direct drive systems with frequency drives, which increases their maintenance cost across the board and their energy usage, and their lack of skilled labor that they can find in the industry. It gets a lot harder to find people to service these types of fans. It does require more of a deft hand in rigging equipment to get those systems out, in engineering to cut holes in buildings where the units were almost designed around it. And Q-PAC is committed to delivering an improved efficiency and continuity through the fan systems technology to make the arrays just simple and easy to install to increase efficiency across the board. And when we talk about the Q-PAC system, we do talk about the entire thing. We are in a complete integrated system where we provide a custom wall, bulkhead system for any given space, be it an air handler or a custom air handling space, or even an open air space. We also include EC motors, and we use one of all three companies from Germany. Rosenberg, EBM, and Zeal are the top three that we use. The technology is really all the same. They are able to use Modbus 0 to 10, backnet capabilities. We also provide all the controls section for it. This is a single point disconnect in most cases. We also have what we call our quick connect box, which is a power and distribution hub for power and controls to all the fans. And we also include all the wiring harnesses for those fans. So everything is pre-wired from the factory, addressed, and connects to our quick connect box with a set of Molex plugs. So it's very light on what the contractor electrician will have to supply for them. And we'll just go over some of the efficiency differences that you may find out in the field from a belt drive system to a direct drive system to the EC fan array that we would provide, or any EC fan in the industry. Most belt drives, and in fact everything you'll probably find out there at these point in time is being controlled by some kind of AC motor and frequency drive. Whereas on an EC fan, that in essence, that inverter is built onto the back of the motor. It normally comes with all your EMC filters for saving on harmonics, integrated controls. It acts like a brushless DC motor. So it converts your AC power incoming to DC and then cleans that signal up and then sends it back to the stator winding on AC power. And it's controlled by a section of gates, and that voltage reduction is controlled by those gates to control the RPM speed. So you don't need belts or pulleys or shafts for any one of these. There are no additional components. The Zeal and all these motor manufacturers build the motors and the impellers, and then they're balanced together as one whole module system. That's why they can be rigidly mounted through the AMCO certification. There's no extra additional vibration required. They can just round straight onto the wall, so you don't have vibration isolators or cork insulation or anything like that. And we don't have some of the slip losses that you would have from an internal rotor motor with a shaft and those bearings, because most of the time, like Baldor marathons will have those shafts. There's a loss in there on top of the VFD losses. Most of those losses are already included in the motor's efficiency that we give you as a percentage of total fan efficiency. And most of the time, our fans are less than about 150 pounds, so can be carried by about 2 people in most cases. Most of the fans are less than 100 pounds. So it does make changeouts awfully easy. They're normally held onto the wall by 8 bolts. And our walls will have fan trays on them to help you put them on. So it doesn't require rigging equipment or massive amounts of time and shutdown for the air handler system to replace those motors. And normally about 30 minutes to an hour, you could have a Q-PAC fan replaced in the system and have the air handler back up and running fairly quickly. There is no maintenance required on any of these fans. They are plug and play. They have bearing lives of anywhere about 50,000 to 80,000 hours is what they consider their L10. So somewhere between 6 to 8, 9, 10 years is really where you'll see these fans last. We do offer a full 5-year warranty from Q-PAC on all of our parts. And like I said, with a faster field installation, we also have integrated redundancy. In most cases, we do N+1. We can do N+2, or we can get you really close on just a straight N system. And in most cases, once these systems are installed, the EC fans tend to be much more efficient than what was previously in there. And by the time the system's balanced, even a system that was not considered full redundant, about 80 to 90%, turns out to be fully redundant because they'll end up having to detune the fans and slow them down a bit more than they expected because of the savings in static pressure that you would get by opening the airflow through these kind of systems. And mostly, like when you're looking at total fan efficiency from all these different type applications, a belt drive system is about 15 to 35% efficient. Direct drives anywhere from 20 to 42, and EC fans can run anywhere from about 35 to 70%, depending on where they operate on their performance curves. So just a good snapshot, and we talk about motor efficiencies, Baldor, Marathon, those AC motors tend to be anywhere like they say 89 to 92% efficient, but that's at full load. Once you start running things on partial load, the efficiency of these fans really starts to fall off in a hurry. Once you start getting under 50% speed, your efficiency standards really go away. EC fans tend to hold that high efficiency between 90 to 95% efficiency, and we're talking motor efficiency, not total fan, upwards to about 30% speed, and then the fall off for EC fans efficiency starts to kick in there because we don't have some of the losses in heat, and some of the bearing losses that you get from those VFDs. We tend to be a little bit higher on the efficiency across the board. And one of the things that we do get asked a lot about, and what's a very misconception, is that EC fans have a higher THD than AC fans, and that's simply not true. While they both use similar 6-pulse inverted drives, the EMC filters and the other filters that are built into those EC fans do lower the THD straight out of the box. So if your system that you're replacing or looking at has a VFD system already in there, but there are no active or passive filters, then putting an EC fan will inherently give you anywhere from 10 to 20% savings in total harmonic distortion. And normally I would recommend, unless you're looking at a hospital where there's MRI machines or CAT scan machines or data centers with very sensitive equipment near the mechanical room, that an active or passive filter isn't required. They're very expensive and they can eliminate your THD less than 5%. But most cases, those equipments will already be in place to protect the equipment that's around it. So I like to go over to THD. We'll go over our quick connect box because this is what makes Q-PAC Q-PAC. This is our biggest feature that we offer. This distribution hub, and it's a small box you see on the left. Every wiring harness will plug into that box, and that will send out power and control to all the other fans so they all operate independently. So if you lose one of the fans, the other 7 in this case would ramp up to compensate for that one lost fan. And it doesn't matter if we lose 1 or 2 or 3. The system is very independent and operates like that. We also provide all the wiring harnesses for replacements as well. If you ever needed a replacement fan, you would just give us the fan number in that array and that job number, and then we can provide you a replacement fan with a whip and wiring harness already installed that just snaps right back into place. So one of the things we'd like to talk about is the comparison between our competition. And like we kind of talked about, fan cubes typically need to be disassembled and then reassembled inside the air handler, which takes a lot of time. They're heavier, so there's always rigging equipment that needs to be installed. They're going to have individual VFDs in most cases. So there's field wiring and programming, which adds a lot more labor cost to the job. Typically, the installation time for a Q-PAC type system or even any EC fan system is about 3 to 4 times faster. So there's a lot less labor hours and scheduling can be done a lot quicker by looking at a Q-PAC fan array system versus something like that. Warranties are a big issue for drive systems. They're normally less than 2 years between Baldor and any whatever kind of frequency drive that they offer. And Q-PAC offers a 5-year warranty on everything as standard. No extra fees need to be paid. And we discussed the fact that when a fan does require a shutdown of the air handler, rigging time and all that stuff really needs to be taken into account. And Q-PAC's replacements take about 30 minutes. And this is such a big issue is that I sell to a lot of clients is the post-installation service for EC versus AC. It does require nothing else than to just watch them and let them run, and no bearings to have to grease and go back to and all that replacement time to get a 15 to 20 horsepower motor out of some of these systems takes hours. Then unless they have one sitting on the shelf somewhere, they have to go and get it, bring it back in there, and you're talking of 500-600 pound motor that you've got to get into a mechanical elevator, get it through a doorway. All of our fans are the widest fan that Q-PAC offers is about 19 inches wide. So it'll fit through any standard mechanical doorway, most access doors and air handlers. It doesn't require any additional work to get it around. So it does make it easier getting in those tight spaces in basements and mezzanines, or even getting them onto the rooftops. So it's something to consider when we look at our competition here. And we do offer two different kind of control panels. My primary reason to discuss even with the basic one is for the smallest type applications that provides you your disconnect, your 0 to 10, an HOA switch, and a local potentiometer for bypassing any of the, if the controller would ever die, your 0 to 10, you would always have a way to manually put that in there and dial your RPM in as you would need it. I always recommend premium controls. The cost difference between a basic and premium is minimal compared to the benefits that you get. Having the individual fan alarm statuses, the safety and interlocks, the power monitoring, the digital display, and the backnet capability, is really worth all of the technical advances that you get over the basics. And then we just kind of go over the system. Again, we use mostly lower power consumption. We can go up to about 9.5, 10 inches of static on most fan arrays. But once you start getting above 7 or 8 inches of static, you really start getting into the upper limits of EC fans. Their power draw at that point of running at full speed really gets to be almost comparable to an AC solution with a drive. So at that point, it becomes more about redundancy, post-installation service, and the benefits of being able to change those things out quickly, because the ROI energy efficiency at those higher end statics are much a longer payback. The bread and butter range for an EC fan is really between about 2 inches and 7 inches. In most cases, ROIs can be anywhere from between 18 to about 48 months, depending on where it's located in the country, what the operating hours are. But those tend to be some of the benefits and where we like to see most of the payback. We do offer full technical support. We've got a great team we do field supervision, that'll come out to the job site during install, help with any technical issues on site. But even if you don't have that service, we do offer it over the phone 24 hours a day. So these are just some of the key contacts for Q-PAC. Myself, there's my email. My sales operation manager down in Jacksonville, Florida, his email's there in the event you can't get in touch with me. He's there locally with all the engineers and supply, can get everything done. And for any technical questions about the companies or the technology that we use, or any questions about how the wiring and things fit, our head technical manager, James Montgomery's email's here, our office phone number. So that is our presentation. I'll open it up for any questions.
Well, thanks, Aaron. I appreciate the information. Just so everyone knows, next week, this says Fans Reimagined. We, of course, just had that conversation today. But next week, we'll be talking with American Aldi's about airflow regulators. So hopefully you'll be able to join in then. But please do type in any questions that you have into the chat. And a question that I'm often asked, Aaron, is about airflow monitoring. Is that something that can be built into the fans themselves?
So the fans all have the ability to do that. Every fan has its own K factor, so it doesn't matter what size it is. There's a long equation to figure out what that airflow is in relative to the RPM and the input voltage. With our premium controls that we do offer, it does all that calculation work for you. But even with the basic controls, if you know your input voltage and the fan, we can kind of figure out what airflow each fan's putting out just basically by their K factor and running the equation.
Are you able to forecast a percentage of accuracy on that number? 5%?
Normally it's within 5%.
Okay, gotcha. So if we're going to replace a let's say a module, one of these fans, it's not just a motor replacement, it's a fan and motor combination together, correct?
Correct. So you've got your, whether it be a belt drive system, all of it will be removed. The wheel, the housing, the bearings, the shaft, and all of that stuff will be replaced. And in that wall that it's being mounted into will be cut open, and you'll have a giant wide open space. And then this fan array system will just snap into place. We provide the top and bottom mounting supports, and then every bulkhead wall panel, depending on how many there are in that particular package, be it 7 or 15, they'll each be labeled 1 through whatever number the final one is. So you'll know which panel you're installing in which order. And as for the fans that get shipped in, they will also have their own designated spot on that array. Fan 1 will go on fan 1 spot, so the wiring harnesses go back and they're all addressed the same.
So one of the benefits I see from that type of system is you need not have an even number, a 2x4 array. You could have a 2x4 plus 1 array in order to try and fit that wall. Is that right?
Correct. So, I mean, most cases we end up we're filling the space more with sheet metal than we are with fans. We can do any from a 2-pack, a 1-pack, all the way to we've done a 48-pack system for an insurance office complex. So there's no limit to the size of fans. It does add in more disconnects depending on how many fans we put into an array. But we are limited on the height of each panel. The maximum height that we can do on our bulkhead is about 140 inches. Doesn't mean that we can't go above it. It just means that we need structural support to put another panel on top of that. So our engineering team down in Jacksonville will be working with the contractor and the reps for those type systems that require a higher height than 140 inches.
And as far as EC motors go, when we think about AC induction, there's a synchronous speed that we always refer to. Is there such a thing with EC motors? And if so, does that line up with the synchronous speeds we might know of from induction motors?
So when you're looking at an AC motor like a Ballador Marathon, they're normally rated by poles. You got 2 poles, 4 poles, 6 poles, and that really dictates how many RPMs there are. So for EC fans, pretty much every manufacturer uses what we call a 12-pole winding. And they're all rated for whatever the maximum is of that particular impeller that is being mounted to it. Like a small 355 millimeter, about a 12, 13-inch impeller can spin up to about 3,300 RPMs. And that's just to keep their efficiencies rated inside. They could probably spin close to 4,000 if they really wanted to. But whatever the fan is rated for is the maximum. They're not allowed to be overdriven. So that 0 to 10 volt input range is what the available power is of that fan. So it's unlike a VFD where you can run it at 60, 80, hertz to overdrive that motor. EC fans are capped at the power and RPM provided by the manufacturer.
Gotcha. And, I'm a Nittany Lion, so this doesn't mind for me so much, but I have other clients like the Utes here in Utah who might not like blue, BYU blue so much. Is there a reason why the fans are blue?
So the fans that come, all the blue fans you'll see come from a company called Ziegelbag in Germany, and that is their corporate color. The other manufacturing offerings, be it Rosenberg or EBM PAPs, mostly use aluminum impellers, so they won't be painted at all. Unlikely to have Zeal give us a custom color, mainly because of the volume that we would require them to create a custom paint job. But no, unfortunately, I'm a Clemson fan, so my color is orange, so I have to deal with blue, and that's just the way it has to be.
Great. Well, I do appreciate the time and effort today. Well done, Aaron. And of course, if you have any other questions or concerns on anything Q-PAC or any of the other products we've been presenting over the past few weeks, please give your long salesperson a call, and we'll be more than happy to assist you on any particular questions or concerns that you might have. But thanks again. Hope you can join us next week for American Aldi's, and have a great day.
Thank you.